As Vu said, I'm Scott Gerlach, the CSO and founder. Hey, look at that. It almost looks like me. That's crazy. The CSO and founder of StackHawk. I was the CISO at SendGrid for 3 years, and I was a senior security architect at GoDaddy for 9 years. Outside of that, when I'm not doing these things, security things, got an awesome wife and kids, brew beer, golf, break other random electronics around the house, and then try to put them back together, etc. If you want to chat with me, you can hit me up on Twitter, and my LinkedIn handle is there as well. So AppSec problem overview. Let's talk about application security, API security, just kind of quickly. It's good in theory, right? There's a bunch of tools out there that can help you make sure you're developing secure APIs, applications, and they kind of get categorized in these buckets. These are good places to start, and we're talking about some of the things that go into each of these buckets. So you've got static code analysis and software composition analysis. Sorry, I skipped a part. Why do you want good API security? Theoretically, you're publishing your APIs that people can get to. They're handling customer data or some kind of data that is potentially sensitive. And you don't want a mistake in your code or in a library or something else to expose a threat actor path into that data and ruin reputation with your customers, with your investors, if you have investors, anybody else like that, because it takes a lot of time and effort to recover from those kinds of things. So that's why we're talking about application security today. Back to the tools that we can talk about. Static code analysis, software composition analysis. These two things are looking at code that you've written and code that you've included that someone else wrote to see if there are interesting ways or problems with how you wrote code or vulnerabilities that exist in libraries that you're using. So pulled in libraries to build stuff. Oftentimes these things are noisy. They lack application context and how it's used, specifically static code analysis. They don't really have a great grasp of how code is flowing through how you wrote it. And then software composition analysis can tell you if you've included a library with an issue, but it can't tell you if you're exposing it in the way that it is vulnerable. So some interesting things there. And they're always language dependent. So if you're developing in Java, you're in good shape. If you're developing in Rust, less coverage. If you're developing in Go, decent coverage, those kinds of things. So there's definitely language dependency issues there. Dynamic code analysis, looking at code that while it's running, so inspecting runtime, testing inputs and outputs. This is specifically useful in API security. Testing inputs and outputs to make sure that the application is handling that data the right way is better and actually understands the context of how the application is using. Still can be a little bit noisy, and the biggest hit here is it's usually harder to use. And then there's these other tools that are out there called RASP, Runtime Application Security, IAST, WAF. And these things are basically, I did the best job that I could, and these are my backstop in production. So these things should be able to tell me if a threat actor is trying to actively exploit something in production. So I want to talk about 3 different things that security teams are doing that kind of makes your life as a developer not awesome. And we'll start with problem number 1. The problem number 1 is the benevolent security team or lack thereof. And this is a little tongue-in-cheek because I'm a security guy. But the hard truth here is you can never hire as many AppSec people as the organization can hire developers. So as you're hiring people that engineer and write APIs, to get really good AppSec one-to-one coverage, you'd have to hire about 1 application security person per 5-ish developers, which is super hard. And it makes it really hard in the name of accountability, but kind of what they're doing at that point is making people go slow or cause interruptions because they can't scale with the business. So you can often see this come in as application security team will go, hey, before you deploy stuff to production, I need to check it and okay it, or loop me into your release process so that I can make sure it's okay. And that doesn't scale really well. And the thing that I like to there's this whole trust issue thing that's going on with security teams and developer teams. And this is Charlie Miller is a really famous application security guy, super wicked smart. And he tweeted this last year. It's almost been a year since he tweeted this. So I got to update this slide. But he said, I'm not sure if a new hire dev is ever in a position to evaluate risk for a feature, product, or company. I think professional security people can do this better. And the hard fact of the matter is everyone can probably do it the same way. It's just how we're focusing on things. So security people and developers think about things differently. And they go about like this. So devs tend to care about things that they can instrument and have knowledge about and action. And the other thing that security teams care about is kind of security, and somewhere down the line is feelings. But obviously, caring about things that you can know about easily and action easily and instrument easily is super important. And that's why security ends up typically on the bottom of this list, because it's really hard to know. There's a barrier to entry in the security industry. But it's not that devs don't care about security, it's that it's hard for them to know about it. So I kind of like to think of this thing a little bit differently that Charlie said, and I think of it more like this. I wouldn't want to put a new hired developer in the position of making an uninformed risk decision, which is much, much different than making risk decisions. Uninformed risk decisions are different. And what you want people to be able to do is have the knowledge that they need or have a tool that can tell them, hey, you should be paying attention to this thing, versus I don't have a thing that I can use. And so I've got to either trust some other team to take care of it for me or just passively make a decision that it should be pretty good. Usually what happens when security teams are kind of in this thing, they often come up with this awesome, great idea that is, let's teach developers how to be AppSec professionals. Because if they know how attackers think, they'll be able to test like an attacker, and that turns into hack yourself. And there's so many problems with this. Number one of them is you're already a developer. You already have a ton to learn about technology and frameworks and libraries and how to scale an application, all these good things. But now we're trying to teach you a different whole different job. So there's 11 billion new acronyms to learn. You got to talk about risk and what that means and how to calculate risk. Also, before we do any of that, you know that the internet is a bad place, right? So like all these conversations start off in a weird position, trying to teach developers how to be AppSec people when we're not ever teaching AppSec people how to be developers. So this whole relationship needs to be more of a collaboration where there is a security team. Notice I prefaced that at the beginning of this. And then if any of your developers have any developers out there have ever went to a security training, it's usually the highest end developer or the lead or somebody that's really good at writing code and really good at being fast and scalable that gets to go to those things. And then they're expected to come back and teach other developers how to do the same stuff. But they're also super busy doing their real job. Security teams also have this nasty habit of wanting to eliminate all risks and patch everything and don't do anything in the cloud, kind of that all-encompassing all or nothing mantra. But business kind of exists to take risks, and that risk, the idea that you can provide a solution to a customer is even a risk. And you need to be able to make measured and informed risks to operate to operate the business, and security is no different in that. So thinking about what things should I prioritize and why is just as important as, hey, we found a bunch of problems. And so this chase to perfection kind of turns into we have to fix all these issues we ever found. And then the questions I always ask when we're talking about this as a security team is, what's the actual risk in the context of the business? And it would be very similar to if your QA team filed thousands of tickets for bugs that are unlikely to degrade user experience. Sure, they're bugs. Maybe you want to fix them at some point, but if they're not going to get in the way of the customer and it's more of a tech debt or operational thing, when does it need to happen? When does it actually need to happen? So that's kind of the problem that security teams like to pile onto development teams. Like, I found all these things to fix all of them. We have to fix all of them now. Again, that's if you have a security team. If you don't have a security team, these things start popping in your head. Where do I even start with this stuff? And then it quickly degrades to, oh my God, forget it. I got other things to do. And wait, maybe my DevOps team can handle it. But if you're a developer or an engineer or a VP of engineering or a CTO, it's hard to take on this mantra of we've got to do security, because it's such an overwhelming thing. And so many companies have to pay the security tax to even kind of get started in that path. And then by the security tax, I mean hire a security professional that is in charge of doing security things, and buying a lot of expensive tools, when there's other things that you can do as an engineering team to start down the security path that can help snowball into, when it gets bigger, it gets into a better spot. And when it starts scaling out, we don't have to do as much rework, so we can focus on scaling. Problem number 2 is AppSec tools, application security tools, API security tools are built for security teams. And so I've included a picture of what an application security tool actually looks like here. Be careful, because it could hurt your eyes. This is not an actual application security tool, but this is what they feel like when you, even as a security person, when you get your hands on them. Tons of buttons, tons of switches, tons of options. And it basically is I'm not going to use this if you try to get this in front of an engineer. So if you're an engineer working on API security and a security team goes, or a security vendor goes, hey, look, I've got a tool you can use and it looks like this, you're either throwing it away or maybe slightly mocking its user interface for a short period of time and then throwing it away. But neither of those things is what you want to do. Security teams also build all these security products in a security person language. So here we're talking about cross-site request forgery, of which there is 2 acronyms for, because we couldn't decide on one of them. And the descriptions of these things don't tell you about the fix. So the real fix here is using the same site attribute in cookies, and most frameworks implement anti-CSRF tokens. And basically what you're trying to do is turn those things on. So turn on anti-CSRF tokens and use them to be able to protect against this thing. Hilariously, none of these things say that. And so trying to convince developers to learn all this language and these acronyms and all these things is tricky. And this is exactly how tools come up. There are a bunch of good AppSec tools for devs out there, API security tools. These are developer native tools in the context of how they work. So they're on the command line, or they're in the IDE, or they can be involved in the CI/CD build pipeline. And Sneak and FOSS and NPM Audit, those are, as well as GitHub and OWASP Dependency Check, those are all software composition analysis tools. There are more and more coming out. And there's one that I work for, strangely, that I think is really good. And we're trying to build that in for, developers. So developers can use that, check it while they're writing code, check it into the pipeline, do the same thing. And that's really important, being able to get into that development workflow so that it's not this side project in the CI/CD or DevOps Mobius. Lastly, and worst of all of these security tools that are for applications, APIs, suffer from the production bias. And the production bias is something that I have a lot of passion about, because it causes a lot of problems in how you test applications and test APIs for security. But let's dig into it a little bit. So the people part of this problem here is these are the people that usually interact with APIs or applications, and it's the security team, in an AppSec function, security team and the pen tester teams, or external pen testers. And the security team is where they know the app the best. Like, they're not accustomed to how do I build this or develop it on my local machine? They just know there's a thing in production that they have to worry about. And the pen tester, production is their only point of access. So they don't have access to build repositories or CI/CD pipelines or any of that stuff. And both of these groups are primarily focused on finding of vulnerabilities, and that's where they get their kind of derive their value out of. The more things I find, the more better it is, or the more better I've done my job. and that creates a lot of repercussions that are the antithesis of what you want to be doing for API security. These are more focused on the number of things that are found than finding and fixing the right things. So being able to find early, fix, push to production. This is more, hey, I found 30 things because I did my job so well. It's also very inefficient because the finders are often not the fixers. So the people that are finding these security bugs also cannot fix them. So they have to do that ticket shuffle of, here's the Jira ticket about the thing that I found, please go fix it. And then it also reinforces this adversarial relationship that exists between security teams and development teams. Specifically that, hey, I broke your stuff. Isn't that super cool? And here's a bunch of tickets and more work, which is not awesome. The timing on when security testing is happening is really inefficient as well. And so there's two places that a lot of security teams and security tools get involved in API application security, and they are right before a deploy to production. So hey, before you deploy this to production, once it's done in CI/CD, let me know. I'll check it for you and make sure it's A-okay, and then you can release it. So that blessing mode application security. And usually what happens is people go, stop doing that. It's slowing us down. And then they move to this playing catch up mode, which is, all right, cool, just push it to production and I'll check it there. And AppSec tools that are run in production are used kind of infrequently, like on a weekly basis or after release. And they all suffer from what I like to call the pants problem. So if your API serves a shopping cart, and the shopping cart or the store sells pants, there's probably a handful of routes in the API that is display the pant size, put the pants in the cart, et cetera, et cetera, et cetera. But because you're selling so many pants in your application or in your API, these security testing tools in production are going to test every single page that they can find, which means you're testing these same routes over and over and over and over and over and over and over, which is why those scans really take a long time, and they have to be run at night on a weekend so they don't take the cart down. But kind of the last problem with this production bias thing is, and it's a really important one, all the bugs are in production. So necessarily having to push your security bugs onto the internet, whether that's production or a public staging site or whatever it is, so that you can find security bugs, is just the worst backwards way of thinking. And when I say the worst backwards way of thinking, you could know about all the things that you're about to push to production if you could check while you're running code in CI/CD and then make active decisions about what actually makes it there. And there may be a time when you're like, yeah, we're pushing these to production, but we will fix them later. And that's an active decision versus we have to push them all out there and hope we can find them and hope no one else does. And so that is kind of this is why I really, really dislike this. I dislike it as a security person. I dislike it as a person that tries to engage engineering teams to be able to be efficient and produce high quality software in a fast fashion. So lastly, we've got kind of the context. The engineers have usually moved on to other sprint tasks or other features or other products once stuff has made it to production and it passes the sniff test or the canary test or whatever you're doing in production to go, yep, we're all good, on to production, moving on to something else. And then the next thing that has to happen is then the security scan or the security checker comes by and goes, yep, tickets into the backlog. It also makes it very hard to identify micro-segmented apps that make up one giant app or one giant API. So if you've got microservices that are backing an API, being able to test those microservices by themselves, A, makes the test faster, B, makes fixing that stuff faster because you don't have to backtrack it to where does this code actually live from production to actual code. And then C, you don't have to play ticket kicking back and forth. So I found a problem on app.something. And so now I got to send it to an engineering team. That engineering team goes, oh, it's actually in this other code repo that this other team owns. And then when it gets there, that team goes, oh, we actually don't own that code anymore. So then you ticket kick it again. And it's just super inefficient and lacks kind of business context of why some things are important to be fixed. Because you're playing so much ticket kicking, usually the people that are building these microservices have a great idea of what data is being handled in them and why it's important to the business. And so empowering those people to get that information early, way before production, is super important. Let's talk about getting started or revamping or how can I in kind of the right way. So if you think about this in terms of development, in test-driven security, how test-driven security should work. If you think about it in test-driven development terms, when you write code and you know the syntax is wrong because it doesn't compile. When you merge code, you know there's a problem because it won't merge. When you run unit tests, you know the code is wrong because it fails unit tests. When you run the integration tests, you know the code is wrong because it doesn't work as designed. Security should work like this. API security should work like this. When a team introduces a vulnerability into an API, they should know because it fails a security test. And that is 100% one of the biggest problems in API security today, being able to know about that early and often and be able to back it up in CI/CD pipelines, check it locally, etc. And so when that should actually be happening is kind of this left side of the DevOps Mobius here during coding and building. So those are perfect places to be testing, which is why we do linter tests there and why we do unit tests and integration tests right here in writing code and building code. Giving feedback to engineers as you're writing code is super important. So ensuring that this is where the security part of the lifecycle has a lot of focus. I'm not saying that it doesn't also belong on the upside for monitor and operate, right? Because there might be some stuff there, but if you're starting an application security program, start here. If you're trying to evolve an application security program or add it to your API work that you're doing, start here. Don't try to start in production and make your way backwards. It just won't work super well. Lastly, API best practices are your best friends here. Use technology to make your life easier. Standardization and automation. Defining packages used to build technology is not only good practice and mostly required to build things, but it can enable understanding of security issues introduced by those packages. So SCA can help there. Generating open API specs for the APIs that you're developing is not only preferred, but it enables so many other great tools like Postman and like tools that can consume open API specs and test them based on that. It's so much better. And then lastly, seed the database and test that data set. Don't avoid that pants problem that I was talking about. Avoid testing the production data sets. Seed the database, test all your routes in there, and do what you can for testing on smaller data sets. If you have a security team, I guarantee you're going to have one of these sessions at some point. You may need a few therapy sessions to be able to kind of convince your security teams that you should own this and you want to run these tools and you want to engage them as your partner to help you go, I don't understand what this thing is, or I think it's this. What do you think about it? And when should we fix it? So heads up, if you have a security team, a therapy session or two may be in the future. And then lastly, just choose an application or service to start. Choose a technology, either SCA or dynamic application security testing. I think those are both really highly actionable. They both tell you both different things about your application. One's about the source or the libraries you're bringing in. The other one's about testing your running application. And then integrate that into the build pipeline and make sure that you're putting out high quality code, not only in unit tests, but in security tests. And then from there, iterate and expand. And then move on to other projects, other teams, get other people in your organization involved. And now I'm totally out of time, and I'm going to make Vu happy and be done with my presentation 2 minutes early so he can make it to his next one on time. If you want a demo of a great DAST tool, there's a demo of StackHawk right after this, and you can kind of come see how that works. Any questions out in the Slido? Vu, any questions you saw somewhere that I didn't see?
We just have some questions in the Slido.
Hit me.
Okay, so the most recent, in case of microservices, when the issue is getting kicked among several teams, can the security test be run just as another unit test? This way the team owns it.
Yeah, absolutely. And that's what it should be, right? It should be there's a test against the microservice so that the team knows that they're making a problem. And that is one of those production bias problems of putting everything together, testing it in production, and then going, I don't know, where does this even live? What code base is this in? Who owns it? All that good stuff.
Awesome. So Greg asks, what's your opinion on training QA members to do AppSec in the context of a small startup?
I think it's great. I think training QA members to do quality assurance, security is part of quality. So not training them to be application security specialists, but training them to be able to consume output from security tools and go, I know what this kind of means and we should prioritize fixing it or not. It's very similar to most QA jobs today, and being able to help their development teams that they're supporting prioritize what things to fix.
Awesome. And I think you previously answered this question in your presentation, but feel free to answer again. Can the security scan be done in stage or UAT environment?
Yeah, absolutely. So that's, to me, I think about it like this. A security scan should be able to run on a laptop or a desktop where you're writing code. So while you're writing it, you can test in CI/CD, in staging, in some pre-prod environment. And then lastly, maybe in prod. Maybe in prod if you need to like back yourself up and go, I just want to make sure.
Awesome. This is great stuff. Does anybody else have any more questions? We have about 5 minutes left before the session closes. Because there's no other session at the moment. There'll be a 30-minute break before the next session.
Ooh, I get extra time.
Yeah. Feel free to pick Scott's brain. He had a lot of great content here. I quoted a couple of them, but that was just barely a gist of it.
Yeah, I'm staring at the Slido just in case more come in. I think that's...
Any suggestions for tools to use while development time?
Yeah, totally. So all of those SCA tools are really good. So I love Sneak. They're good friends of mine. Fossa is a local to my area, so I'm in Denver, Colorado. They're in the same area. They're good friends. But if you can't afford kind of those tools that give you a little bit extra above and beyond what GitHub Dependabot does, GitHub Dependabot does a great job of going, hey, you've got vulnerabilities and it's free. The extras you get are from those commercial tools and you can upgrade and you should upgrade versus these packages are out of date. I think, obviously, I think StackHawk is a really good one, but that's just my highly biased opinion. And there's a handful of other ones that are out there as well. Static code analysis tools are usually pretty expensive. I think SonarQube has a free version of it, and it can give you some good insights. But again, if you use that, you might find it noisy. It takes a little bit to tune.
Wow. Yeah. No, that was great.
Awesome.
So a couple of folks asked for your contact information. So thanks for adding your Twitter and email.
Yeah,
and
you
your
bet.
Website.
Are we posting slides somewhere later?
I can't speak about the slides, but this presentation will be on YouTube and the reception shortly after.
Okay, cool. If anyone needs this slide deck or wants this slide deck, reach out to me on Twitter or at my StackHawk email or on LinkedIn. I will ship them to you.
We had a question from Aishwari. Can you open your last slide again with the conclusion?
The last slide. This one?
Yes.
Sorry, I was looking at. Now I need to know. Anything particular you want me to talk about here, Ashwari? Okay, maybe you just needed to see the slide.
We have 2 minutes before the session auto closes. But I just want to make an announcement. Again, thanks, Scott. This is really great. I learned a lot. Also, for every 5 developers, you need 1 security personnel. So something to mention about the conference is that we have Expo Hall booth. So if you drop by, a lot of them are giving out prizes and swag just for stopping by and talking to folks. The more booths you enter, the more chances to win. We have a photo booth also, and we have a great couple of hours left of content.
Definitely goes for the StackHawk booth. The StackHawk team is out there, and we're giving away sweet swag.
Ooh, okay.
Jordan's even wearing his StackHawk shirt today. How awesome is that?
So can Postman employees win swag too?
Sure.
I'm just kidding. I'm already decked out in my Postman hoodie.
Vu, if you just wear StackHawk swag all the time, I'll send you a bunch of it.
Okay.
Awesome. Thanks, everyone, for coming to the talk and listening to me rant on about application security. Hope it was useful. If anyone has any questions, please reach out.
Awesome. Thanks, Scott. This is amazing.
Yeah, thank you.